Hey, what's going on, guys? xiangqi here. So I managed to write a chess mode generator on basic programming language for ZX Spectrum, believe it or not. Okay, so the code base has grown and the entire mode generator is here from line number 500 to this one. So what I have added so far is, apart from the board, I've added the side to move, the variable holding the side to move. This code just initializes the board array. Then here is the function to print the board, and we skip this, so we go to line number 220 after initializing the board. And here we go with this a bit more initializations. So this is a way to distinguish between the slider and leaper pieces. So we initialize the piece types, kind of like. Here is the p-square table. So this array is exactly the same, has exactly the same layout as the board array, and it contains the scores of how many points a given piece would score on a given piece. So let's say on E4 it would be more, on E3 it would be less, on A0 it would be like no score at all. So generally this idea p-square tables would encourage a chess piece to move towards the center. Okay, then the piece weights also is what would be needed for evaluation. So the relative value of pieces, so like pawn, knight is worth of 3 pawns, bishop is worth of 3 pawns and 50, and the negative values for blacks, because we're going to be using the eninge search algorithm, which needs to negate the score depending on side to move. So initializing the weights. Now, one of the most essential things for mode generation purposes. So here is the array with here is the data set, the data constants containing the values for move offset for every single given piece. So pawn can go forwards 1 square, forwards 2 square, white pawn, and capture diagonally, and then all the rest of pieces like white knight, white bishop, white rook, white queen, white king. Then black pawn goes the opposite direction, black knight, black bishop, black rook, black queen, black king. So we do initialize this into the two-dimensional array. I know this is not the fastest ever solution, but I really don't feel like comfortable with this basic programming language. So I just try to make it, just trying to write the minimal amount of code at the very end. And here is the mode generator. So it's pretty similar to what we've been doing so far in our minimalist engine called Tyfish. So this sort of a part, it's really similar to this part. So just try to implement this in basic. So what we have here, let's quickly have a look. Okay, so we loop over the board squares. I just skip the first squares, like I skip squares from this to this just to save the processing power, and also skip from this to this. So we loop from this square and up to this one, and this off-board squares are being skipped. So here's how it's happening. So loop over the board squares if hold on a sec. Yeah, okay, so if the board square, if the board square is off board or the empty square, then we well, here we can continue to the next iteration. Okay, then initializing the piece whatever located at board square. Then we need to make sure that we take only pieces of our side to move, otherwise we continue to the next iteration. And if it is so, then we go to the next line, and then we loop over 8 directions, because here we have like up to 8 directions, but obviously we want to skip those directions contained in 0. So just I decided to initialize this 0 elements just to avoid branching within the mode generator code, so just to make it faster, actually, literally. So if the direction is equal to 0, then we continue again. Otherwise, we do initialize the offset, initializing the target square, and now we loop over the offset, over the attack ray, so like square by square. So this loop is only needed for sliding pieces. So down below here we can say that if we have a leaper piece, then we just drop out of this loop, so we're not going more than one iteration. Okay, then if we capture opponent's piece, then we break from the loop again. Then here so we like updating the target square, so target square equals target square plus offset. And by the way, here I can use this offset variable. I just separated this variable as well. Okay, just I'll change this later on. So captured piece is whatever is located at board at target square. So if we capture enough board, then we break out of the loop, or in this case, we can break many times in basic programming language, believe it or not. Within the do loop, we can break only once. Therefore, I'm using then continue for, so continuing the outer for loop, the for loop where this do loop loop exists within. Okay, so what else? So if capture enough board, then we continue. If we have, if captured piece is not equal to empty square, and and it's capturing our own piece, then we again, like, we continue the loop or break out of the loop. It's just the same thing, but just to be said a bit differently. And here are the set of rules to define the pawn moves. So if a piece is white pawn or black pawn and offset is diagonal, and the captured piece is equal to 0, so if we don't capture diagonally anything, then we break. So we disallow pawn moving diagonally if there is no piece there. Okay, then if we have white or black pawn and we have the frontal offset, so white or black pieces like +1 square or +2 square, and if there is something, if that square is occupied by the piece, then we then we're not doing this move again, like breaking from the loop. But in this implementation, we're going to continue the current for loop. So it's a bit weird to understand, but you can observe this then continue for as just like as break. So just have a look at this code in Python, or in C would it be the same. We're just breaking out of the while loop. So we just break here, and what we do here is absolutely the same, but just written as continue for. Okay, then if we have white pawn which moves double, and it's a double pawn push, and if there is something in between, so if it's jumping over the piece, in this case we need to disallow it, so break. In case same for black pieces. And the final test, so we need to make sure that if we have a double push for either white pawn or black pawn, we need to make sure that the source square lies within the second rank or within the 7th rank for black. Second for white, second is the 7th for black. Okay, then we just make a move the following way. So we erase the source square, we put a piece on the target square. This goes up 160, just prints the board, nothing special. So we just go to 160 here. It's the routine to print the board. We return, and when we return, the instruction pointer points here again, like to line number 700, and then we go further on. Then we then we do the take and move back. Then we take the move back. So board at the source square, we restore the piece there, and at the target square we restore the captured piece, if any, and then we print the board again. This is pretty it. So without further ado, let me compile and run this in the emulator. So here we go, compiling, and I'm using Fuse emulator, as you probably already know. So I can say file, open, and basic tab. And here is how the chess engine is working if you see this from within. So it just takes all the moves currently. So this is going to be a king capture engine, so king capture is going to be possible, but it would be revealed on the next iteration, like on the next supplier would be revealed the king is captured, hence deadline would be dropped. So At the moment, it's kind of like a pseudo-legal move generator, but this was a little bit too easy. So let's alter the position slide a little bit to give an idea of how, how other moves are being generated. So here, let's say we put a position like, so here, let's say e2, e2, e4, e7, e5, and let's also put things like here, it's going to be like c7, c6, and here like b2 to b3. So now it's white's turn to move. Okay, so move, 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 move. Yeah, so it's white turn to move, and let's have a look how the moves are going to be generated in this case. So compile the code again and run the code, and here we go. So the position is updated. You saw like this pawn only moved one square, nothing much. Okay, so bishop is moving, queen is now moving. Okay, bishop, now knight goes to 3 squares, and we're done. Well, I don't know, it doesn't look impressive, but it's incredibly difficult to write this in basic programming language, believe it or not, guys. So yeah, if you want to torture yourself, then definitely you should try this. Otherwise, I don't recommend this sort of thing. But yeah, this is it from my side. So hopefully, I would implement evaluation and search next, and the game loop. So actually, if I ever succeed with this sort of a program, then I believe that the next video would be the demonstration of the end result. If I find something interesting, like in between step, I would share that as well. Okay guys, this is it from my side, so thanks for watching. Until the next time, and take care.